Okay, in this video, we're going to be doing problem set 89 from Calc AB. The problems and a playlist are in the description below, and let's take a look. So we've got, this is a definite calculator problem, like you're not doing without one. Let f of x equal x squared minus 3x plus 4. If the tangent line at x equals -1 is used to approximate f of x, on what interval to 3 decimal places is the approximation within 0.5 of the true value? So we have not done a question like this before, but let's just think it through, right? So I definitely need a tangent line, so I'm going to find the equation of the tangent line, which means I need to know the value of the function, so I need f of -1, which is going to be 1 plus 3 plus 4, so 8. I need to know f prime, so f prime is 2x minus 3. I need f prime of -1, which is going to be -2 minus 3, so -5. And now I need to write the tangent line, so I'm going to write that in point slope form. So the tangent line is y minus 8 equals -5 quantity x plus 1. All right, that's our tangent line. Now, we want the value that we get from the tangent line to be within 0.5 of the true value of the function. So I want the absolute value of the difference between f of x and the tangent line to be less than 0.5. That's what we need. So I'm going to write that down. I need the absolute value of f of x, the true value, minus the quantity 8 minus 5x plus 1. That's the tangent line value. I need all of that to be less than 0.5. So there's multiple ways you can handle this on the calculator. What I chose to do on the first shot was I just used solve, right? I defined f of x and then I tried to solve f of x minus the quantity 8 minus 5, quantity x plus 1, less than 0.5. And the calculator solves it. It gives you negative 1.707, let's say, to 3 decimal places, is less than x is less than negative 0.293 if we're going to 3 decimal places. As long as you choose an x that's in that interval, the tangent line approximation will be within 0.5 of the actual value. That's what this question is asking. Now, if solve doesn't work on your calculator or whatever, if something goes wrong, an alternative approach is to just graph this thing, right? So here I have graphed the actual thing. I graphed the absolute value of f of x minus the tangent line, and then I also graphed 0.5, and I'm just looking for where f of x is less than 0.5, so like between those intersection points, and you can see those intersections are the same as what we got when we use solve. So this would be my answer. It's a really good calculator question. It's a little bit weird because, as I mentioned, I don't think in my class that we did a problem like this. I've not seen one on an AP exam really, but I just thought it was really neat. I was looking through super old AP exams and I saw one that was very similar, so decided to write a question like it. All right, new problem. Given f of x is equal to x cubed minus 3x squared, where x is greater than or equal to 0, honestly, that's there because when I was writing the problem, I didn't know if there would be more than one x value where this happened, and I was a little worried about that. Find the equation of the line tangent to y equals f of x at the point where f prime equals -3. All right, so let's just do it. We got to find f prime. So f prime is going to be 3x squared minus 6x. We are told that f prime equals -3, so let's just set f prime equal to -3. And that's going to look like 3x squared minus 6x equals -3. Now this is algebra. Bring the 3 over, and we get this. Factor a 3 out, and we get this. X squared minus 2x plus 1 is just the quantity x minus 1 squared. So we have 3, the quantity x minus 1 squared equals 0. And the only x value that makes that true is x equals 1, which means I didn't really need the restriction x is greater than or equal to 0, but I had it anyway. All right, and then the problem is find the equation of the line tangent. So we need to know the value of the function. We already know the value of the derivative is -3. That's like the premise of the problem. So if you go back to f of x, which is x cubed minus 3x squared, and you plug in 1, f of 1 is 1 minus 3, so -2. And then if we write our tangent line in point slope form, because that's what we do, we'll have y plus 2 equals -3 quantity x minus 1. Kind of an interesting problem, had like a little variation on what you usually end up doing. All right, let's take a look at the next one. Based on the graph of f of x shown above, put f of 2, f prime of 2, and f double prime of 2 in order from least to greatest. All right, so we just need to like come up with them. When you're doing a problem like this, I kind of firmly believe that they will all have to either be 0 or have opposite signs, because otherwise it's going to be really challenging to put them in order. So when I look at the graph, f of 2 is definitely 0. Like we can just see that. If we sketch in a tangent line, you can see that the slope of the tangent line is definitely negative. You could also see the function's decreasing at that point. However you want to deal with that, f prime of 2 is less than 0. And then if you look at the concavity, this thing is definitely concave up on this interval. I don't think I chose the best colors for that, but definitely concave up, which means f double prime is greater than 0. And we do have the scenario where they all have different signs or are 0, because I think that has to happen. So I'm going to say, therefore, f prime of 2, the negative one, is less than f of 2, the one that's 0, is less than f double prime of 2, the one that was positive. And that's from least to greatest. So just don't freak out. Just do the problem, right? Like, you know how to do it. You just got to think about it. All right, let's do one more. I don't know why I wrote this problem. I don't even like this problem. It doesn't like tell you anything. If f is a linear function, so like f could be y equals mx plus b. That's a linear function, right? And 0 is less than a is less than b. What is the integral from a to b of f prime of x dx? I don't know. Just do it. Like, you run into these types of calculus problems a lot where you're like looking at the problem, you're like, is there a bigger concept here? Am I supposed to learn something by doing this? I don't think this is one of those. I think you just dive in and do the problem. So like I said, mx plus b fits the bill. I know the derivative is definitely just the slope. So I'm going to say f prime of x is equal to m. So the problem is really just do the integral from a to b of m dx. So that's going to be a rectangle that is m high and has a base of b minus a. So m times b minus a. You could also use the fundamental theorem and do like mx, where x goes from a to b. So then you have m times the quantity b minus a. Like, however you want to do it, you're going to get the same answer. I don't know. I don't like the problem, but I write the problems far ahead, and then when I solve them, I'm just like, what was I thinking? Like, was I thinking something else? I don't really know. But this is the problem. Problem set's over. I hope this was helpful, and good luck.